Best practices for Docker. Using Docker effectively and securely involves following best practices to ensure your containerized applications run smoothly, are easily maintainable, and maintain a high level of security. Here are some essential best practices for working with Docker. Use official images. Whenever possible, use official Docker images from trusted sources like Docker Hub. Official images are maintained by the software's creators and are regularly updated with security patches. Create minimal images. Build lightweight images by starting with a base image that contains only what your application needs. This reduces the attack surface and improves image size and efficiency. Single responsibility principle. Follow the single responsibility principle when building images. Each container should have a single purpose, which promotes easier troubleshooting and scaling. Use version tags. Tag your images with version numbers or meaningful labels to keep track of changes and ensure consistent deployments. Use Docker ignore. Create a Docker ignore file in your application's directory to exclude unnecessary files from being added to the image. This reduces the image size and build time. Minimize layers. Minimize the number of layers in your images to improve performance and reduce complexity. Each instruction in your Docker file creates a new layer. Use multi-stage builds. Utilize multi-stage builds to create intermediate images that compile, build, and prepare your application. Then, copy only the necessary artifacts to the final image. Leverage caching. Leverage Docker's caching mechanism by ordering your Docker file instructions from least frequently changed to most frequently changed. This speeds up builds by reusing cached layers. Secure your images. 1. Scan your images for vulnerabilities using tools like Docker Security Scanning, Trivy, or Claire. 2. Use Content Trust, DCT, to sign and verify images to ensure their integrity. 3. Avoid including sensitive data in your images. 3. Use environment variables or secrets instead. Network isolation. 1. Use Docker's network modes, such as bridge, host, or overlay, to isolate containers and control network access. 2. Avoid using net equals host unless absolutely necessary, as it exposes the container's network stack to the host. Volume mounting. Use volume mounts to persist data that needs to survive container restarts or be shared between containers. Service orchestration. 1. For larger deployments, consider using Docker Swarm or Kubernetes for container orchestration and scaling. 2. Use Docker Compose for local development and testing of multi-container applications. Monitoring and logging. 1. Integrate monitoring and logging tools to track the health and performance of your containers. 2. Send logs to centralized logging systems for easier troubleshooting. Container lifecycle. 1. Use the room flag or implement proper container cleanup mechanisms to remove containers after they stop. 2. Avoid running unnecessary processes in the background. 2. Containers should be designed to run the application or service directly. Regular updates. 1. Keep your Docker installation and images up to date to benefit from security patches and bug fixes. 2. Regularly update your application code, dependencies, and base images. Documentation. Maintain clear documentation for your Docker files, images, and deployment processes. This helps ensure smooth collaboration and future maintenance. Remember that Docker best practices can evolve over time, so it's important to stay up to date with the latest recommendations from the Docker community and security experts. Tips for writing efficient Docker files. Writing efficient Docker files is crucial for building lightweight, optimized Docker images that provide better performance, security, and manageability. Here are some tips to help you write efficient Docker files. Start with a lean base image. Choose a minimal and appropriate base image for your application. Alpine Linux-based images are often recommended for their small size and security features. Use multi-stage builds. Utilize multi-stage builds to create intermediate images for building and compiling your application. This helps separate build dependencies from the final image and reduces image size. Combine commands. Combine multiple commands in a single run instruction using shell concatenation or the symbol to reduce the number of layers in your image. Minimize the number of layers. Limit the number of layers in your Docker file by grouping similar instructions together. Fewer layers mean faster builds and smaller images. Order instructions carefully. 1. Place frequently changing instructions, like copy, towards the end of your Docker file to leverage caching. 2. Place less frequently changing instructions, like package installations, earlier to improve build speed. Clean up after installations. 1. Remove unnecessary package caches and installation files in the same run instruction after installing packages. 2. Use and interchain package installations and cleanup in a single run command. Use specific version tags. Specify explicit version tags for package installations to ensure consistency across builds. Avoid using latest as it might lead to unexpected changes. Use copy over ADD. Prefer the copy instruction over ADD for copying files into your image. ADD has additional functionality that's unnecessary for simple file copying. Leverage. Docker ignore. Create a Docker ignore file to exclude unnecessary files and directories from being added to the image. This reduces the image size and build time. Use env for configuration. Use the env instruction to set environment variables in your image. This makes your image more configurable and reduces the need for hard coding. Minimize run commands. Consolidate multiple run commands into a single run instruction to avoid creating additional layers. Use entry points and CMD. 1. Define an appropriate CMD instruction that specifies the default command for your container. 2. Use an entrypoint instruction to define the main executable for the container. 2. This helps avoid unnecessary wrapper scripts. Avoid running unnecessary services. Containers should run the main application directly. Avoid starting unnecessary services or daemons inside the container. Label your images. Add metadata labels to your images using the label instruction. These labels can provide useful information about the image, its version, and its maintainers. Test and iterate. Regularly build and test your Docker images to ensure they work as expected. Make small changes and iterate to optimize your Docker files over time. Documentation. Include comments in your Docker file to explain the purpose and reasoning behind each instruction. This helps others understand your image construction process. Remember that Docker file efficiency contributes to faster builds, smaller images, and better overall performance. By following these tips, you can create more streamlined and optimized Docker images for your applications. Security best practices for Docker containers. Ensuring the security of your Docker containers is paramount to prevent vulnerabilities and unauthorized access. Here are essential security best practices to follow when working with Docker containers. Use official images. Whenever possible, use official images from reputable sources like Docker Hub. These images are maintained by the software's creators and often come with security patches. Regularly update images. Keep your base images and application images up to date by regularly pulling the latest versions to incorporate security updates. Minimize attack surface. 1. Start with a minimal base image to reduce the number of unnecessary packages and services. 2. Remove or disable unnecessary software, tools, and libraries within the container. Use multi-stage builds. Utilize multi-stage builds to separate build dependencies from the final runtime image. This reduces the attack surface and image size. Limit container capabilities. 1. Use the cap drop and cap add flags to restrict the Linux capabilities available to the container. 2. Avoid running containers as the root user whenever possible. Use user namespaces. Enable user namespaces to map container users to less privileged users on the host, reducing the potential impact of container breakout. Scan for vulnerabilities. 1. Use container vulnerability scanning tools like Trivy, Claire, or Docker security scanning to identify security issues in your images. 2. Integrate image scanning into your CI/CD pipeline to catch vulnerabilities early. Implement network segmentation. 1. Use Docker's network modes to isolate containers and control network access. 2. Avoid using net equals host unless absolutely necessary, as it exposes the container's network stack to the host. Secure secrets and sensitive data. 1. Use environment variables or Docker secrets for sensitive data like passwords and API keys. 2. Avoid hardcoding sensitive data directly into your Docker files. Limit volume mounts. 1. Limit volume mounts to only necessary directories. 2. Avoid mounting sensitive system directories from the host into the container. Use Content Trust, DCT. Enable Docker Content Trust to ensure images are signed and verified before being deployed. Monitor and audit containers. 1. Implement container monitoring and logging tools to track container behavior. 2. Regularly review logs and analyze metrics for suspicious activities. Implement proper entry points and CMD. 1. Define entry points and commands that run the application directly, avoiding the use of shells or unnecessary processes. Avoid running as root. 1. Whenever possible, configure containers to run as non-root users. 2. Use the user instruction to specify a non-root user for running the application. Segment containers. 1. Use Docker Compose or Swarm to isolate containers in separate networks, ensuring they can only communicate as necessary. Regularly audit and update images. 1. Periodically review and update your container images to incorporate the latest security patches and updates. 2. Set up automated image updates to streamline this process. By following these security best practices, you can significantly reduce the risk of security vulnerabilities and unauthorized access in your Docker containers. Remember that security is an ongoing process, and staying informed about the latest security practices and threats is essential for maintaining a secure container environment. Thanks for watching.